Let's look at another example. We have two equations here, y equals negative x plus 2 and y equals x minus 4, and they're asking us to solve this linear system of equations, or essentially what they're asking us is to find the point of intersection between these two lines. And we're going to do this without graphing. So without graphing, what we do, the first step is let's label the equations. So I'm going to label this as equation 1 and equation 2. And same thing, since we know that both of these are going to share one point, and that point is going to have x and y coordinates, so we're going to let equation 1 equals to equation 2, right? So let equation 1 equals to equation 2, solve for x. Okay, so let's do that. Negative x plus 2, which happens to be equation 1, equals to x minus 4. Now let's put all the x's on one side of the equal sign. So we have minus x. Let's move this x to the other side. It becomes minus x. The 2, this positive 2, when we move to the other side, it becomes negative 2, and the negative 4 remains there. So minus x becomes minus 2x, and here we have minus 6. Now let's get rid of this negative 2. So this negative 2 is multiplying here, goes dividing on the other side, so we end up with negative 6 over negative 2. The minuses cancel out, and 6 divided by 2 is equal to 3. So our x coordinate now we know is going to be 3. Okay, now we're going to use this and substitute it into one of these equations, to figure out our y coordinate. Okay, so I'm gonna use equation 2 again. So we take, and let's just describe this for a second. We're gonna substitute x equals 3 into equation 2, and so let's do that right now. Equation 2 happens to be y equals, I'll use a different color for this, x minus 4, so we're gonna have 3 instead of the x, minus 4, and what is 3 minus 4 gives us minus 1, and that's it. We know what our point of intersection is, so we can say therefore the point of intersection between these two lines is, and we have 3 because it's our x value, and y is equal to negative 1. Right, notice that if we take the 3 and substitute it into the first equation, which was minus x plus 2, right, so it would have turned out to be negative 3 plus 2, which gives us negative 1, would have given us the same answer. Alright, so let's just keep that in mind, and this is our solution. We have solved the system of linear equations. Alright, let's look at one more example. Alright, you may pause this video if you want to see another example, but sorry, if you want to pause on that example, let's look at another example here. Right. What if they give us the equations but in standard form? So what if they ask us find the equation 2x plus y plus 6 equals 0 and x minus 3y minus 4 equals 0. And sorry, by the way, just to go back to the previous example, I guess I was getting ahead too quickly. Right, we can also go ahead and graph these two lines of the previous example, right, negative x plus 2 and x minus 4, and we can see that the point of intersection, yes, turns out to be exactly what we expected, right? 3 comma negative 1, which happened to be the point of intersection between these two lines, and we showed how to get that algebraically. Alright, so perhaps you can try this other example that I gave you and see what you come up with. Here's one hint: if you're stuck with it, you can just turn that into one of these into slope-intercept form and substitute it in the other, and then the same process. So for x, then find out what y is.